Alright, this is Mr. P helps with Algebra 2. This is U1T2SLT number 8. We're going to start off with a warm-up, which is a cubed function. And in this case, we can talk about transformations. This is a transformation of the point of symmetry is going to be left 2, because remember, whatever's on the inside is always the opposite, 1, 2. And down 3, 1, 2, 3, because of the minus 3 on the outside. Since there is no number on the outside, that means the next number is going to be 1 above, because it's really times 1. So the next point is going to be 1 above it, which means the previous one's going to be 1 below it. Now I need to find at least 2 more points, and I'm going to test 0 as the domain. So 0 plus 2 is 2, 2 cubed is 8, 8 minus 3 is 5. So f of 0 is 5, which means, and I could also test the one that came before it. Negative 4 plus 2 is negative 2, negative 2 cubed is negative 8. Negative 8 minus 3 is negative 11. So negative 4, negative 11, which just barely fits. And there's my cubed function. Okay, so if I did the inverse of this, it would be going this direction like that, and that would still be a function, which we're going to be doing today, which is inverse of a quadratic, which is a squared. All right, so solidifying. So there's this story about how much time you need in order to stop, how much distance you need in order to stop when you're going a certain speed. And you're going to use a formula 0.03 times x squared. Think about it for a minute. What factors might make the difference of how far it takes for a car to travel to stop after hitting the brakes? Well, whether it's rainy or whether it's maybe there's snow on the floor, how fast you're going would make a difference, how big your tires would make a difference. So there's lots of outside factors that could make a difference. So we're going to assume that for whatever car this is, this happens to be some Ferrari, that 0.03 times x squared. So the first thing you want to do is put that into your graphic calculator, or you could just simply do it by hand. So d of s represents the total distance, d of s, and all you got to do is simply take your calculator and plug that number in. So 0.03 times 55 squared. Now I don't have a calculator handy on me, so you do 55 times itself, then multiply that point by 0.03, and if my memory serves me right, it was like 97 point something. It was a decimal. And then do the same thing for part B. So that's d of s. So your answer is found by taking 0.03, multiplying it by 100 squared. Now I don't need a calculator for this one, so that 100 times itself is that would be 10,000, and then 0.03 times 10,000 would be 300. So it takes 300 feet in order to stop the car going 100 miles per hour. Now, like I said before, I know this one was about 97, something, I think it was around that point. So, which brings me to this last question. So you would think if you're going twice the speed, you would need twice the distance, but that's not actually true. When you're going twice the speed, you actually need way more than that. So it depends on how fast you're going. But in this case, you're going to need like 3 times the distance. So this one, all you got to do is take your answer, which is 300 feet, and divide it by 16 feet. Sorry, divided by 16 feet per car, and that'll tell you how many cars that you need. All right, so when you're graphing this, so this was 0, 0. If you're going 0 speed, you obviously would need 0 distance. 100 was 300. I kind of already set this up already. And 55 was give or take about 97. So what you end up with is a graph that looks like this. Now, it's quadratic, like I said, so it looks like a parabola, but it's only the one side of the parabola because the domain has been restricted to just the positive sides, because you can't have negative speed. That's not possible. Describe both. Okay, so I basically just did describe it. All right, so what if the driver of Ferrari is cruising along and suddenly hits the brakes? So now we're being told that the skid marks were 31 feet long, and you're being asked to find what was the speed squared. So what you would do then is you would first divide it by 0.03. And once you have done that, then you would take the square root of that answer. So I don't know what this answer is, but then you would take the square root of it because you're trying to find s. Because s squared equals whatever this is, 31 divided by 0.03. And then take the square root of both sides, and that's going to give you your answer. Same thing for this one. So put 15 feet in for the answer, and then solve for s. All right, pen's not working out so well. All right, so getting to the next part. So this is where we're going to do the inverse. So basically, I would do the exact same things I did before, only instead of putting 100 300 feet, I'm going to put 300 feet and 100 miles per hour. So you're doing everything backwards. So the equation is going to be the inverse in this case. So that means that the speed is equal to it's going to be, well, just y equals, I guess I could say. So y equals the square root of x divided by 0.03. Because that's the inverse, because remember before it was times 0.03 squared and then times 0.03. So it was x squared times 0.03. So x would be squared first, squared would be first, and then multiplied by 0.03. So you do the opposite operations in opposite order. So that's going to be divided by 0.03 and then take the square root, because that's the opposite of squared. Alright, so when you do that, you're going to get the exact opposite. So remember, the last one went like this. This one's going to end up going like this, because this is kind of like that. It's the inverse of this kind of graph. Because remember, inverse literally means that you're taking it and you're reflecting it over the y equals x. So now, keep in mind that our domain was restricted to just the positive side, which means that this would be the inverse of this. But if you have the entire parabola, which I think is going to be the next question, then you do the inverse, it's not going to be a function. So you can't ensure that's a function. The way to ensure it's a function is to limit the domain to only the positive side. So you have only this side of what used to be the parabola as your answer. And I think I just answered basically all of those questions. Is the inverse? Yeah, I definitely answered that one. So what do you notice about the graph compared to was relationship? Okay, yes, yes, I already mentioned all that. All right, moving on. Homework. Baseball is hit in an upward fashion at 3 feet in initial upward from a height of 3 feet in initial velocity of 80 feet per second. So you can tell that the rate of change in the very beginning is going up really, really, really fast. And then it's going to slow down, slow down, slow down, slow down until it's not going up at all. And then it's going to start heading back down. So its rate of change is changing constantly. At the very, very beginning, it's going up 80 feet per second. But by the time it hit the first second, it had only gone 67 feet. And by the second second, it had gone 99 feet. And then at the third second, it's also at 99 feet. And at the fourth second, it looks like it's 67. And at the fifth second, it looks like it hits back down to 3 feet. All right, approximate the time a ball would hit its maximum height. So that's between the second and the third second. So that would be about 2.5 seconds. Approximate the time the ball hits the ground. 5 seconds? Give or take. It's approximate. It'll be a little bit further because it's actually 3 feet above the ground. At what time is the ball 67 feet above the ground? At 1 second and 4 seconds. And then it says make a new graph with new heights. Okay, so make a new graph that shows the time when the ball was hit with the given heights. Okay, so we want to reverse everything around. So using the heights times, you would go 0, 1, 2, 3, 4, 5. Okay, so you're basically just doing the inverse here. 1, 2, 3, 4, 5. That's obviously not equal. And then this way, you're going to do a much better job than I am. So this way, I'm going to go 0, 25, 50, 75, 100. So this way, when were the two times when it hit 3 feet? So it hit at 0 and 5 seconds. So that would be like right here and right here. 67 feet at 2 times 1 second and 4 seconds, like here and here. And then 99 feet at right here and here. So what you're noticing is that the graph is looking like the inverse. All right. Thanks again for watching. Please give it a like to help you learn something about the inverses of these functions. And please subscribe if you haven't done so already. Thanks again for watching.